Welcome to the debate. Right up front, I want to mention that this discussion is an idea for hot foot, bringing listeners a clear look at multiple perspectives on today's topic. So I want you to imagine writing a recipe.
Okay, a recipe.
Yeah, but a recipe so incredibly valuable that entire nations are literally threatening to go to war over who gets to actually bake the cake.
Right, which sounds crazy, but
It does. Because usually, when we think about building something important, we picture the whole process happening in one single place. You gather your materials, you put them together, and you control the final product right there in your own workshop.
well, yeah, because it just makes logical sense. I mean, when you control the workshop from start to finish, you know exactly what is happening at every step. You don't have to rely on anyone else. You have complete independence.
Exactly. But imagine a totally different system. Imagine if you only focused on writing the perfect recipe. And then, and this is where it gets wild, you sent that recipe to a highly specialized team in Europe who built the oven.
Okay.
Then you sent it to someone in Japan who expertly mixed these invisible chemical ingredients. And finally, someone in Taiwan actually bakes the cake for you in a factory the size of a city.
I mean, honestly, that sounds like a logistical nightmare.
Right?
It sounds incredibly complicated and, frankly, highly risky. But as wild as it sounds, that is exactly how the modern world works right now. Only obviously we aren't baking cakes. We are building microchips.
Exactly. And that is the core of our discussion today. Chips are, well, they're the tiny electronic brains inside absolutely everything we use. They run our phones, our cars, our internet, our hospitals.
Military jets, too?
Yes, military jets. Without them, the modern world literally stops instantly. And this entire global system, it started in one very specific place. Back in 1947, inside America's Bell Labs, this tiny microscopic switch was born. It was called the transistor.
And it's really crucial to remember that this tiny switch didn't just grow up in a normal, peaceful business market. Not at all. It grew up inside the intense, paranoid pressure of the Cold War.
Oh, absolutely.
Throughout the 1950s and 1960s, America was racing the Soviets to the moon. They were building nuclear missiles. Because of that, the United States Pentagon and NASA, they bought nearly every single early chip that was made.
Yeah, they needed them desperately.
Right. They paid absolutely any price, and they asked zero questions.
Which, if you think about it, provided an incredible engine for pure innovation. I mean, that guaranteed government money let the brilliant minds in Silicon Valley take wild, expensive risks.
Oh, for sure.
And they scaled up at breathtaking speed. So, by the 1970s, the United States owned the global semiconductor industry completely. American companies designed the chips, and American factories built them.
Until they didn't.
Right. Then the industry hit a massive turning point. America made a massive choice. They decided to slowly stop making the physical chips and only focus on designing them.
And that choice brings us right to the central question we are debating today.
Exactly. When America decided to walk away from manufacturing chips and only focus on designing the blueprints, was it a brilliant strategy for global efficiency, or was it the most dangerous mistake in industrial history?
A big question.
And is.
And I argue that splitting up the work, where America thinks and designs while other countries physically build, it actually created a brilliant, highly efficient global system that made today's incredible technology possible.
Well, I take the exact opposite stance. I argue that abandoning that dirty, hands-on factory work was a terrible miscalculation. By treating physical manufacturing as something beneath them, America left the world's technology supply chain dangerously fragile with absolutely zero backup plans.
Okay, well, let me start by explaining my position in a bit more detail. I really believe that the American shift toward pure design in the 1970s and 80s was not a mistake at all. It was just a smart, natural evolution of a really complex business.
How so?
Well, think about how incredibly difficult it is to run a modern chip factory. It takes literally billions of dollars just to build one, and then the equipment gets old and outdated within just a few years.
It's a massive capital drain.
Exactly. So by letting go of the physical factories, American companies freed themselves from this massive financial anchor. They could focus all their brain power, all their resources, on pure innovation.
So you're talking about companies like NVIDIA, AMD, and Apple.
I am. Those companies are the most valuable tech giants in the world today, and they don't actually build the physical chips they sell.
Right, they outsource it.
They are pure thinkers. They draw the microscopic maps, and because they didn't have to worry about running messy, super expensive factories, they could push the boundaries of what a chip could actually do. They created this brilliant global order where everyone simply does what they do best.
The thinkers think and the builders build.
Exactly. Specialization is the ultimate form of evolution.
Okay, I hear your argument about evolution, but I come at it from a completely different direction.
Okay.
I believe that giving up manufacturing was the most expensive miscalculation in modern industrial history, period. Those early days of guaranteed government money, yeah, they allowed America to lead the world. But that incredible success made American companies way too comfortable.
Comfortable? Because they pivoted to a more profitable model?
Comfortable because they fell in love with sitting at a clean desk and designing. They actually started to look down on the physical manufacturing process. They viewed factory work as something messy, difficult, and ultimately beneath them.
But the reality is, they were making so much more money. And they were driving much faster innovation by focusing entirely on design.
Short-term money, certainly. I won't argue with that. But by happily letting the physical factories drift overseas, America lost its control over the physical world.
I think that's a bit of an exaggeration.
No, think about it. They assumed the brains would always stay home and the muscles would be safely managed somewhere else. Today, this choice has resulted in a global supply chain with zero redundancy.
Zero redundancy is a strong term.
But it's true. Redundancy means having a backup plan. If one piece of this global chain breaks today, we have no backup plan. The whole world's technology simply stops working.
Look, I understand the fear of not having a backup. I do. But to really understand why this distributed system works so well, we have to look at the historical mechanisms. We have to look at how the market naturally adapted when challenges arose.
You mean when other countries started eating our lunch?
I mean that the moment America started looking away from the factories, another country realized the true power was in manufacturing perfection.
You are talking about the rise of Japan in the 1980s. And frankly, that is exactly when the immense danger of losing manufacturing first became obvious.
Well,
While America was busy outsourcing its factories and feeling so smart about saving money, Japan was building an absolute fortress around their manufacturing sector.
they certainly took the manufacturing side to a level of precision the world had never seen before. I'll give you that.
Precision is an understatement. The Japanese government understood that chips were the future. So their Ministry of Trade bankrolled massive national research labs. They literally forced their competing tech companies to work together to pool their knowledge.
Right, the VLSI project.
Exactly. And Japanese engineers became completely obsessed with one specific metric: yield.
Right. And for our listeners, yield is a pretty simple concept, but it has massive consequences. It simply means the percentage of perfect, working chips you can get from one piece of raw material.
Because making chips is incredibly hard.
So hard. Even a tiny microscopic speck of dust floating in the room can ruin a whole batch. So if a factory makes 100 chips and 50 are broken or defective, your yield is 50%.
That is a great way to picture it. And with incredible, almost samurai-like discipline, Japanese engineers pushed their yields incredibly high. I mean, they practically eliminated the dust. They eliminated the errors.
They did.
They crushed American yields, which allowed them to undercut American prices drastically. Because they threw away fewer broken chips, they were making better technology for much less money. This changed everything.
It really did shift the landscape.
Sony's simple transistor radio evolved into the Walkman and then the camcorder. These devices became global symbols of Japanese precision.
They absolutely dominated that era of consumer electronics. You couldn't walk down a street without seeing a Walkman.
They truly did. By the mid-1980s, Japan controlled roughly 75% of the world's market for memory chips. It was a stunning reversal of power. In less than a single decade, America's share of the memory market collapsed from 70% down to just 20%.
Which was a massive wake-up call.
It was. And this is the exact miscalculation I am talking about. When you hand over the factory to someone else, you hand over the power.
I hear you, and it sounds like a massive defeat. But look at what actually happened next. The system adapted perfectly. Washington didn't just sit there and let the industry die.
They panicked is what they did.
They struck back, but not by building expensive factories, which would have been inefficient. They struck back by using the political tools of a globalized system. They used the 1985 Plaza Accord.
But the Plaza Accord was a financial agreement. It wasn't a manufacturing breakthrough.
It was a brilliant geopolitical lever. The Plaza Accord was an agreement that forced the value of Japan's currency, the yen, to go way up compared to the US dollar.
Right.
So let's break down how that actually works. If a Japanese company is selling a chip to America for $1 and suddenly the value of their currency doubles, they are forced to sell that exact same chip for $2 just to break even.
Yes, it priced them out.
Overnight, Japan's massive price advantage completely vanished. The spell was broken. Japan could no longer flood the market with dirt-cheap chips.
Okay, I will grant you that the currency manipulation worked to slow Japan down, but forcing a competitor's prices up politically does not mean America won the manufacturing game back. It just means they tripped the runner who was in first place.
But it created a healthy, wide-open space in the global market, and the market quickly found a new, highly efficient player to step into that exact space.
You mean Korea?
Yes. As Japan staggered from those new currency rules, a tiny Korean company seized the opening. In February 1983, the founder of Samsung made a famous announcement called the Tokyo Declaration. He bet his entire massive company group on building memory chips.
And most analysts laughed at him when he said that.
They did.
It was an insane gamble by any rational standard. Korea did not have the technology or the history to pull that off.
They laughed, but within a decade, nobody was laughing anymore. Samsung bought the basic tools from the US and Japan. Their engineers worked around the clock, literally sleeping in the hallways of the factories.
The work ethic was undeniably intense.
Within 6 months, Samsung built a working factory. Within a single year, they successfully designed and shipped a working memory chip. As Japan retreated under US pressure, Korea charged into the memory throne. And honestly, they never left.
Okay, but
To me, this proves the pure brilliance of the global system. The market balanced itself beautifully. When one manufacturer got too powerful or too expensive, another country stepped up to do the physically demanding job perfectly.
I disagree. Relying on sudden currency manipulation by politicians combined with wild, desperate gambles from Korean companies, that doesn't sound like a stable strategy for the most important technology on Earth.
It worked, didn't it?
It sounds like pure luck. But let's look at the next massive shift, because while Korea took over the memory chips, Taiwan took over the actual manufacturing of almost everything else.
And this is where the global system truly became a masterpiece of efficiency. In 1987, a man named Morris Chang founded a company called TSMC in Taiwan.
A huge turning point.
He came up with a radical, brilliant idea. It was called a pure foundry, and the mechanics behind this idea are just fascinating.
Let's make sure we define what a pure foundry actually does, though.
Right, so a pure foundry is a massive factory that only builds chips for other people. TSMC made a strict, ironclad promise. We will only manufacture. We will never design our own chips. Therefore, we will never, ever be in competition with our own customers.
It is a very clever business model, I'll admit that. It solved a massive problem of trust in the industry.
It unlocked the entire modern tech world. Think about it like a secret recipe. Imagine you invent a brilliant billion-dollar recipe for a new type of cookie.
Okay, I like cookies.
You need a massive bakery to make 1 million of them. Before TSMC, if an American design company wanted chips built, they had to ask another American manufacturing company to build them. But those manufacturers also sold their own chips.
Right.
It was like taking your secret cookie recipe to a rival bakery. You would be terrified they might peek at your recipe, steal your ideas, and put you out of business.
So TSMC removed the threat of the rival bakery.
Completely. With TSMC, that fear vanished. Because TSMC swore to only build things and never design them. Tech companies could hand over their most incredibly secret designs without a single worry.
Pure trust.
Yes, pure trust allowed TSMC to build massive, city-sized factories and achieve a scale of production the world had simply never seen.
The rival bakery is a great way to explain the business logic. It really is. But you are completely ignoring the terrifying geopolitical reality behind TSMC.
How so?
This was not just the clever idea from a smart businessman. Taiwan's government backed TSMC heavily with millions of dollars. And they did it because they saw much further than just making corporate profits. They were looking at physical survival.
Wait, how does building computer chips equal physical survival for a country?
Because they created a strategy that became known as the Silicon Shield. Taiwan is a small island located right next to China, and China officially claims that Taiwan belongs to them.
Right, it's a very tense geopolitical situation.
Exactly. Taiwan knew they needed a massive, powerful friend to survive any potential invasion. So, they decided to make themselves so utterly indispensable to the world's economy that no one could afford to lose them.
Oh, I see.
Think about the stakes. If Taiwan makes all the advanced computing chips for American fighter jets, American banks, and American smartphones, then America's military will have to defend Taiwan.
They would defend them out of pure necessity to keep their own country running.
Exactly. Not out of friendship, not out of shared democratic values, out of pure desperate necessity. This proves my entire point. This global supply chain is not built on natural, peaceful business efficiency.
You think it's built on fear?
It is built on geopolitical fear. We handed over the most important physical technology on Earth to an island that is constantly under threat of a military invasion. That is the definition of a dangerous historical miscalculation.
Look, I completely understand the risks involved. It sounds scary, but consider the alternative. A single country trying to build advanced chips entirely alone is like, well, it's like one person trying to build a modern airplane from scratch in their garage.
But
It is physically impossible. Furthermore, the Silicon Shield actually works. It created decades of stability in the region. The fact that everyone needs Taiwan desperately actually prevents conflicts from starting. Because the system is so deeply interconnected, nobody wants to break it.
That theory works perfectly right up until the exact moment someone decides they are willing to break it. Which brings us to the ultimate terrifying result of these historical choices, today's deeply divided semiconductor map.
The map is specialized, yes.
We have 6 countries, one single supply chain, and absolutely zero backups. Let's walk through the physical reality of how fragile this really is.
The reality is highly specialized, yes, but I argue that specialization is a massive strength.
It is not specialization. It is a monopoly at every single step. Let's start in Europe. The Netherlands has exactly one company named ASML. They hold an absolute global monopoly on a technology called EUV lithography.
Which stands for extreme ultraviolet.
Right. And to understand how crazy this is, imagine trying to draw a detailed map of a massive city on a single grain of rice.
You'd need a very small pencil.
Exactly. You cannot use a normal pencil. You need a pencil made of pure light. ASML is the only company on Earth that knows how to build the massive, complex mirrors and lasers required to make that microscopic light pencil. Nobody else in the world can make these machines.
Which is an incredible triumph of human engineering.
It is a dangerous choke point.
But wait, it gets worse. Once you have the machine from the Netherlands, you need the materials from Japan. Japan completely controls the market for photoresists.
Right, the chemicals.
Yes, this is like developing old-school camera film, but at a microscopic level. You have to coat the raw silicon in these invisible, highly specific chemical liquids so the light pencil can carve the tiny roads perfectly. Nobody can replicate Japan's chemical recipes.
And then, of course, the process moves to Taiwan or Korea.
Right. TSMC in Taiwan fabricates over 90% of the world's most advanced computing chips. Meanwhile, Korea's Samsung and SK Hynix completely dominate the specialized memory chips that are currently powering the entire artificial intelligence boom.
It's a relay race.
And finally, China acts as the world's factory floor, assembling the finished electronic products. 6 countries. If one ship gets stuck in a canal, If one chemical factory catches fire, or if one political leader decides to go to war, the entire global chain collapses instantly.
I hear your concern about the fragility. It sounds precarious. But look at how the United States is currently handling the situation with China. The U.S. is actively trying to cut China off from the most advanced AI technology.
Right, the export controls.
Exactly, and they are succeeding. This proves my point perfectly. Because the U.S. still controls the original blueprints and the advanced software, they hold the master keys to the whole system. China is trying to fight back, but they are stuck.
They are stuck on the advanced chips. Yes. But they are fighting back by monopolizing the things America ignored. Because the U.S. cut them off from the bleeding edge technology, China shifted its massive resources into two other areas. First, older, mature 28-nanometer legacy chips.
Right. Legacy chips meaning the basic, everyday chips. They don't run advanced artificial intelligence, but they run almost everything else.
Right. These older chips run our cars, our refrigerators, our 5G internet towers, and even our military weapons. China is aiming to dominate that everyday market completely. But more importantly, China holds a terrifying card: raw materials.
The minerals.
Chips require specific rare minerals like gallium and germanium.
And China controls the global supply of those minerals.
Yes, but let me explain exactly how they control it. It is not that these rocks only exist in the dirt inside China. It is that refining these rocks into usable pure metal is a toxic, highly expensive, and really messy process.
Ah, so other countries didn't want to do it?
Exactly. Other countries didn't want to deal with the pollution or the cost. We outsource the dirty work. Now, China physically controls the keys to the raw materials. The West simply cannot build chips without them. The U.S. is trapped because, after decades of looking down on dirty factory work, it cannot physically build anything itself.
That is a very compelling way to frame the danger, I'll admit. But I maintain that this deeply woven system actually prevents disaster.
How?
The threads of this global network are too tightly tied together for anyone to cut them cleanly. The Netherlands has the laser machines, America has the advanced software and blueprints, Japan has the chemical film, Taiwan has the giant factories, and China has the raw materials.
Right, a house of cards.
No, because it is so deeply woven together, it forces countries to work together even when they hate each other. It creates a global balance of power. No single nation can rule the world and dominate technology alone because they physically need all the other nations just to turn on their computers.
Or you could argue it creates a situation where a single spark could burn the whole forest down. And this time, no new trees will grow. We are locked in a massive standoff, and we threw away our own tools decades ago.
Well, we have explored a tremendous amount of history and complex mechanics today. I think it is the perfect time to bring our thoughts together and summarize our positions clearly.
I agree. It's been a deep dive.
So, to summarize my position, I believe that the American strategy of separating the brain from the hands was a massive, brilliant success. By stepping away from the incredibly expensive and messy physical factories, the greatest thinkers were allowed to just think. It created a beautiful, specialized system where every country becomes a master at one specific task. The United States designs the brilliant blueprints. Europe builds the impossible laser machines. Japan perfectly mixes the chemical film, and Taiwan bakes the physical chips.
Right.
This massive global team is a masterpiece of human cooperation. This highly specialized system is exactly why we have smartphones in our pockets and why the artificial intelligence boom is happening right now. It brought us the future much faster than if one country tried to do it all alone in their own workshop.
And to summarize my position, I believe that this global strategy is a terrifying mistake. By deciding that building things with our own hands was too messy, too expensive, or somehow beneath us, America gave up its true independence.
Okay.
We traded long-term security for short-term corporate profits. Now the entire modern world is trapped in a system with absolutely zero backups. If one machine breaks in Europe, or if China decides to stop shipping one type of refined rock, or if a conflict starts near the island of Taiwan, the entire modern world stops working.
It's a stark warning.
We handed the physical keys of our civilization to other people, and we are just hoping they never lock the door.
We certainly disagree on whether the current global setup is a beautiful triumph of efficiency or a highly dangerous trap, but I think we have found a very strong point of agreement today.
Oh, definitely.
We both absolutely agree that the current global chip war is not really just about tiny pieces of silicon.
Not at all. It is about raw power. It is about who gets to write the rules of the next century. Whoever controls the flow of these tiny microscopic switches controls the military, the global economy, and the very future of artificial intelligence.
That is precisely the point. It is genuinely fascinating to think about how much of our daily lives relies on these tiny, invisible switches and the massive global journey they take before they reach our hands.
It really is.
We encourage you to look deeper into the history of this material and decide for yourself. When America put down the factory tools to pick up the design pen, did they create a brilliant success of global teamwork or a fragile mistake that threatens our future?
It really comes back to your opening thought about baking that cake. When the recipe is spread across 6 different countries, you really have to wonder what happens when just one of those kitchens decides to close its doors forever.
A great question to leave hanging in the air. Thank you for joining us on this deep dive. We will see you next time on The Debate.